A few months ago, I was diagnosed with ADHD, or Attention Deficit Hyperactivity Disorder, which was about as surprising as finding out that Brandon chamfers his cheese.
What?
Now, in case you're unfamiliar with this linguistic roller coaster, this specific type of neurological debuff that I've been dealt means that I get bored of things really quickly, and maintaining concentration is hard. So, with that crucial plot device established, I invite you to cast your mind back to 2017. Look, the 90s revival was a thing back then, alright? The iPhone X comes out to confuse anyone not familiar with the concept of Roman numerals, whilst the roll-safe meme is all the rage, along with a few noteworthy mentions. A bloke goes viral for sprinkling salt in an overly dramatic fashion, and Bitcoin served to make some people briefly rich and permanently insufferable. It was, objectively, one of the years of all time. And yet, one trend stood above the rest. Fidget spinners. Seriously, they're like proverbial confetti, scattered in just about every corner of the internet, and even the scary world of not internet, colloquially known as the outside. Unless, of course, you or me. You see, I like to present as a bit of a contrarian in life, and part of this edgy personality trait is going against the grain of what's popular, which is why, a whole 8 years later, and because 10 is too mainstream, I decided to make one. My reasoning? Well, there was a whole misconception about fidget spinners helping with concentration. Even though it was complete and utter bollocks, I'm not one to shy away from a daft idea. And besides, it seems like I'm purposely going out of my way not to tick this box. With all of that in mind, CAD was the logical start to this idea. And as soon as I finished that, I found the best place for it. Like any good project, this one starts by turning up the difficulty level on a manual machine a notch by adding a fourth axis, also known as a rotary table. Why have 3 axes when you can have 4? Because all the features are going to be machined in situ, the position of the part doesn't actually matter a great deal, but in order to do that, I first need to find the center of the table, or the pivot point. I actually like this rotary table, and I'd like to keep it additional hole free, so I'll use this sheet of brass to protect it, as well as serve as a warning that I've probably gone too far. With the center drilled out to my largest drill, I can utilize one of my least favorite tools, the boring head. A boring head is a bit like if you took a lathe, stood it upright, and inverted all the controls. Or, to put it simply, fucking awkward. The starting point is a scratch pass, which gives me a 0 position that all the remaining features will revolve around. You're then supposed to use the markings on the lead screw to check your depth of cut, although they're more of an optimistic suggestion than an actual means of measurement. Normally, this step alone would dissuade me from even touching this thing, but I recently learned a trick from my friend Francis at Project Havoc, which makes dialing accurate cuts possible. Using a dial indicator to check the depth of cut effectively eliminates any backlash from the mechanism and instead provides a true reading. Side note, but if you like my videos, there's a very strong chance you'll enjoy his videos too. The humour is top notch and the cinematography makes me consider different creative outlets. Finger painting perhaps, or fridge magnet design. As tedious as boring heads are, the accuracy is hard to argue with, and this just scratches the surface of what they can really do. And this is a great example of why boring heads are boring. Every cut you take requires this choreographed routine just to advance the cut by a very small amount. I guess the clue's in the name. Right, let's see. Lucky or good? Well, that looks rather promising, but the proof is in the fitting. That's about as close to an interference fit as I could hope for. Just what I wanted. Although this is where it gets rather sketchy. You see, the design calls for these 20mm radius cutouts, and try as I might, cutting a concave arc on a rotary table with a fixed pivot point was simply not happening. So I thought about it, and after thinking about it some more, I remembered that a boring head is really just a fly cutter with extra steps. The previous cut left the diameter of the boring head set to just a smidge under 19mm, so adding another 11 will get me to exactly where I need to be. And because the sketchiness factor is already cranked up to the eyeballs, I might as well throw caution to the wind and reduce the number of clamps. Once I've hogged most of the material away, I'll feed the boring head down to clean up the wall of the cut. The emotion I'm feeling right now is that of pleasant surprise. I didn't think this would work as well as it did. One down, 2 to go. Unsurprisingly, adding a little bit of WD-40 helps massively. Isn't hindsight wonderful? Whilst there is an upper limit to the depth of cut, the same principle applies when going the other way too, especially when approaching the end of remaining material. Coincidentally, the moment you find this out directly corresponds to the unscheduled time for a sphincter control test. I mean, I guess it beats manual deburring. Clearance is clearance. All that's missing are some chamfers, which kind of poses a problem. I'd like to use my chamfer mill for this, but the diameter is too small for the boring head. Some sort of an adapter is in order. Alright, maybe something a little bit more substantial. Come on, say it with me. That ain't going anywhere. So, it turns out a perfect chamfer is a tad harder to do than I thought. I'll just write this off on artistic license, you can't tell me otherwise. And speaking of artistic license, I'd like to add some decorative patterns, because aesthetics matter. I know that form follows function, but it's important to remember that two things can be true at the same time. Aesthetics can evoke certain feelings and emotions, or simply make you appreciate something that tiny bit— oh, come on! Really? Now? Fine, whatever. So, yeah, anyway, aesthetics matter, but some matter more than others. See? It's absolutely fine, just like I meant it. So for all you nerds out there, the specific alloy I'm using here is 6082. For those who slept through metallurgy classes, that's base aluminium with a dash of magnesium, silicon, manganese and chromium, although for all I know it could be full of melted down beryllium paper clips. There are two reasons for using this. One, it's relatively easy to machine, and two, it's all I could get my hands on. There's also a third reason, but you'll have to watch the rest of the video to find out. And if you like watching these videos, consider checking out my Patreon. It helps me make more of them. In the interest of making this more complicated than it needs to be, I decided to decorate it with a triplet of counterweights. You could argue that this has an effect on the rotational dynamics of the spinner, but really it's just an excuse to make it look better, because aesthetics matter.
Ow!
Unfortunately, my machines don't share the same sentiment when it comes to my fingers. A quick plunge with an end mill takes care of the conical section left by the drills. The boring part is nearly done, I promise. But since I don't want the spinner to be a radial cigar cutter, I need to fill the holes with something. And because I have a tendency to overdo things, I decided that the counterweights needed a bit of pizzazz, so I got PCBWay to make some titanium ones. Grade 5 titanium to be exact, sporting some finely engraved logos too. See, PCBWay don't just make custom printed circuit boards, they also offer 5-axis CNC machining, fabrication, metal 3D printing, and most importantly, freaking lasers, man! Ordering a part is as simple as uploading a CAD model, selecting any features, materials, finish options and tolerances, and hoping for the best. The thing is, there's an actual person on the other side that has to make it, and they'll tell you exactly what can and can't be done, as well as offer advice for the best course of action. In other words, they'll do the hard part of thinking for you. Thanks to PCBWay for sponsoring my increasingly daft ideas. Hey look, it's almost as if I planned this. All that's left now is to free the part from the grips of its fixture. All the burrs left from milling are no bueno, but it's nothing a few swipes of abrasive can't fix. However, nothing quite beats the precision of a turned outer edge, with some chamfers to suit, of course. And just like that, the main piece is complete. Well, almost complete, but we'll get to that. But alas, we're not quite finished just yet, since the spinner needs some bearing caps. And the curse of the stringy aluminium chip continues. Although we can't forget about the chamfers, as well as a small undercut for the thread, so it can be screwed in all the way to the shoulder. Speaking of threads, M5 seemed like a good number. That's the great thing about designing things yourself, you get to pick your own dimensions. Alright, it's just a parting blade, it can't hurt you. It's gonna be fine. Oh, would you look at that? Can I get a counter on the screen? Well, that's one half done. Now I just need to do it again. I've still got it. Once I've got everything nice and concentric, I might as well use the setup to clean up the other side of the bearing cap. You know what? I'm on a roll today. That's not even foreshadowing.
I never get this lucky with farting modes. Nice.
All that's left is to clean the other bearing cap face up and the lathe can be laid to rest. Now, I want to dish out the bearing caps to give them a bit of positive grip. A ball nose end mill would work here, but that's boring, which is a great segue for the next part. One of my favourite things about machining is the problem-solving aspect of it. There are a seemingly infinite number of ways to do something, and setups like this really drive that point home. Granted, if you're a real machinist that somehow found their way to my playground, you're probably scoffing at the idea of me calling this complicated. But hey, let me have my moment. After all, I'm not a machinist, I simply play one on the internet. Some blue die cam lets me see the center point, so I can line up the cutter. It's not exactly precision work, but it's good enough for the lady I go out with. To drive the lathe on its side analogy even further, this is like an inside-out radius cutter, only more unwieldy. I'm kind of impressed how well that worked. However, the other one poses a slight issue. I need a way to hold this in the chuck, but crushing the threads is what I'd consider suboptimal. So, whilst you weren't looking, I made this short spigot to take care of that.
We should make some popcorn.
Yeah, my juice box doesn't need a buddy. Whoa! Here I come!
And just like that, all the machining's done. In my philosophy, a job worth doing is worth overdoing, so I figured a ceramic bearing would be just a thing here. You see, most organically grown bearings tend to be some sort of steel flavour. Yep, that's steel. There is, however, a lab-grown version of that, which is a ceramic bearing. They can normally be found in hostile environments such as a high-performance turbocharger. This thing! Where the speed alone would render a standard bearing about as useful as a ventilated condom. Do I need that kind of spec here? No, of course not. But having a YouTube channel that focuses on making stuff tends to turn the question of why into why not. I made this nylon alignment pin to give the bearing a fighting chance. Since the tolerance is so close, I'll heat the part up to expand it slightly, but it's still important that the bearing goes in straight. And just like that, the two are joined in holy H6 ISO matrimony. I have to say, this is quite mesmerising, and there's most certainly an argument for that sort of industrial look of bare aluminium, but I'd like to repeat myself for the third time this video. Aesthetics matter, which is why I chose to make this thing out of aluminium in the first place. Remember when I said that there's also a third reason? Well, this is it. Another feature of 6082 aluminium is that it anodizes really well, and what's a bit of sulfuric acid poisoning between friends, right? And of course we can't have titanium parts and not apply the same logic to them as well. A few drops of Loctite will mask my less than ideal tolerances on the hole diameters. This colour scheme is no accident, by the way. Even though Colin McRae wasn't around to witness the questionable rise and fall of the fidget spinner, I'm quietly telling myself that he would have appreciated this one. And so, what's the verdict of all of this? Has this really been the silver bullet for the high entropy environment that is my brain? No, of course not. But it is fun, and in some sort of twisted way, that's okay. Perhaps the real treasure was the neurological disorders we failed to cure along the way. Anyway, join me next week for the 1000-degree knife challenge. Perhaps we'll make some slime. Heck, I'll even throw in an Internet Explorer joke in there somewhere. And as always, thanks for watching. I'll see you next time.